Last class we discussed about the theory regarding loop analysis and mesh analysis. How the loop analysis is done, how the mesh analysis is done. Today we will discuss about the application of loop analysis or mesh analysis. Application. So if one problem is given, then how we can solve this problem by the loop analysis. First, the problem is 10 volt source is there and we have 4 ohms, 2 ohms, 4 ohms resistors are there. The question is find out current and voltage across each and every element of the circuit by the loop analysis. First thing, he is mentioned loop analysis only, right? He is asked to find out current and voltage across each and every element. Look at here, number of elements, 10 volts is one element, 4 ohms, 2 ohms, 2 ohms, 4 ohms. At each and every element, this is the active element, remaining all resistors are the passive elements. At each and every element we have to find out the voltage and current, right? For that, you know that already we discussed about the loop analysis theory. In that, the first point is, first check how many loops are there. How many loops are there? Look at here, we have, this is the one loop and this is the two loops. Loops are meshes are 2. Loops are 2. Automatically loop equations also 2. Loop equations also 2. So for that, first again you have to redraw the circuit. That is, this is the 10 volt source having the series connection with the 4 ohms resistor, and it has a parallel connection with the 2 ohms resistor, and again we have a 2 ohms resistor and a 4 ohms resistor. 4 ohms resistor. The first point we have 2 loops and we have 2 loop equations. Next, assume that we have 2 loop currents are there. Assume that the first loop current is the I1 and second loop current is the I2. If we have a 3 loops, then again we have I3. Here, by applying the KVL. So in loop analysis we have to apply the KVL of each and every loop, then we will solve the equations. First loop, for the first loop, what is the first loop here? This is the first loop. This is the first loop. Start from here or start from anywhere, but this is the first loop. For first loop, apply KVL. Apply KVL simply. So by applying the KVL means in a loop or in a mesh, the summation of voltages will be 0. What about this voltage? Actually, this is the source. Source always plus here, minus here. Starting is minus. But these are the elements. From that, just write that. Already, this is the voltage source. So automatically, the voltage is minus 10. What about this resistance voltage? 4 ohms resistance voltage. Voltage value is resistance into current. So this is the element, that's why plus 4 into I1. 4 into I1 plus. What about here? 2. So in this, look at here, one current I1 is entering and I2 current is entering from the another side. So we have again 2 currents. For that plus 2, which loop? First loop. So first loop has I1 positive and I2 is negative. I2 is negative, equal to 0. So this is the condition. I am writing each and every voltage of element of the loop. So from that, so I can simplify this. We have 4I1 plus 2I1 is, this is the 6I1. This is the 6I1. What about I2? Minus 2I2. Minus 2I2 is equal to 10. So take it as the first equation. This is the first loop equation. In that we have 2 unknown things. Same as first loop, you have to write the second loop equation. Second loop is regarding this. This is the second loop. From that, write voltage across this. For the second loop, voltage across this 2 into I2 plus 4 into I2 plus again we have 2, here I2 is entering, I1 is leaving. So, I2 minus I1, I2 minus I1 equal to 0, right. From that, once again 2 into I2 plus 4 into I2 plus 2 into I2 minus I1. I2 is the second loop direction, I1 is the reverse direction of this I2. That is why I2 minus I1. So we have minus 2I1. By simplifying this, we will get minus 2I1. Next, plus 2I2 plus 4I2, 6I2. 6I2 plus 2I2, we have 8I2 equal to 0. 8 equal to, you have to 0. Then this is the second equation. So, by solving these two equations, we will find out the I1 value and I2 value. Look at here, we have two unknowns and two equations. By using the scientific calculator, we will find out the I1 value and I2 value. Here we have I1 value is, by solving this, we will get I1 value is 1.81 amperes and I2 value is 0.45 amperes. So, by using a calculator, you have to find out these values, you will get this, right. But the question is, we are finding the loop currents, this is the flowing current in this loop, this is the flowing current in this loop. But what our requirement, the question is, has to find out the current and voltage across each and every element. So, we will go for the each and every element. First, 10 volts, this is the first thing is the for 10 volts source. 10 volts source, we will look at the 10 volts source. For the 10 volts source, voltage is directly given. For the 10 volts source, voltage is directly given. This is the 10 volts. But current from the source, look at here. Look at here. This is the current from the source. Actually, this is the current from the source. If you observe here, this current Is is nothing but I1. But here I2 is given. But Is, I1 both are same. Is is nothing but I1. That is, what is I1 current here? 1.81 amperes. Understand? This is the voltage value, this is the current value. But for the better to give some numbers, it is very simple. That is why take it as this is the R1, this is the R1 resistor, take it as this is the R2 resistor and this is the R3 resistor and this is the R4 resistor. Then dividing is easy. For R1 resistor, R1, next we will discuss about the R1. So, in order to find out the voltage, what is voltage? Voltage is current into resistance. From that, first current across R1 is nothing but, current across R1 is nothing but, simply what is current flowing here? I1 is flowing here, simply I1 is flowing here. So, I1, what is I1 value? Again 1.81 amperes. What about voltage across R1? Voltage across R1 means current across R1. Current across R1 means nothing but same. Just write it, current across R1 and resistance of R1. Current across R1 is nothing but the I1 current. Both are same. I1 current. What is R1 value? R1 value 4. What is I1 value? 1.81. What is this value? 4. If you solve this, you will get VR1 is 7.24. This is nothing but 7.24 volts. 7.24 volts. This is about the R1 resistor. Next, what about this? Next, we will go for the R2 resistor. Go for the R2 resistor. First, assume that this is the first loop direction. Source is generally flowing like this and like this way. That is fine. The current across R2, first the current across R2, I can write like this. I1 current is entering, I2 current is leaving. I can write I1 minus I2, I1 minus I2. What is I1? I1 is 1.81 minus 0.45. 1.81 minus 0.45. We will get, by simplifying this, we will get 1.36. This is the simply 1.36 amps. Next, what about voltage? Voltage across R2, current across R2 into R2. Current across R2, already we will find 1.36. What about R2 value? R2 value is 2 ohms. R2 value is 2. What is the value? This value is 2.72 volts. This is the voltage across R2. Same voltage across R3. Same across R3 resistor. We will find out the across R3 resistor. For R3 resistor, current across R3, current across R3. If you observe here, current across R3 means I2 current, simply. Current across R2 means simply I2 current. Just nothing but this is the I2 current. What is the value of the I2 current? I2 current value is 0.45 amperes. 0.45 amperes. Next, what about voltage? Voltage across R3 is simply current across R3 into R3. Current across R3 0.45, we know that. And what about voltage across R3? The resistance is 2. 0.45 into, we will get 0.9 volts. Same as you can find out the R4. Same as you can find out the R4 value. You will find out the current across R4 and voltage across R4. This is the procedure. This is the procedure to find the any given circuit or any network. This is the procedure. Simple. First, whenever he mentioned you have to find out current or voltage across any element, just first you find out how many loops available. 2 loops, so 2 loop equations. Then assume that 2 currents, this direction is our, you can take like any direction. Finally the answers will be same. Finally the answers will be same. I am taking the same direction, this is the I1, this is the I2. Then you will go for the KVL, apply the KVL, next step. Simply KVL means the voltages in a loop is 0, the voltages in a mesh is 0. Then simply you will get the one equation and you will get the one equation. So by solving these 2 equations, we will find I1 and I2. Now we have to compare the currents with the each and every element currents and voltages. Then it is very simple. So here 4 ohms is I1, but for 2 ohms I1 minus I2, 2 ohms is nothing but I2 current is flowing. 4 ohms only I2 current is flowing. Like that you have to compare. Then you have to find out each and every element of the current and voltages. From that you can find out the power also. Simply what is power? Power is nothing but voltage into current. I will give you one thing, you will get everyone. What is power? Here power is, what is the power from the, which amount of power will be supplied by the source to each and every element? Simply voltage into current. Voltage into current is nothing but power, you know that the thing. Now voltage is 10 volts, the current is 1.81, you will get 18.1 units are watts. This is DC power. And you can find out the each and every element, resistor 1 power, resistor 2 power, resistor 3 power, resistor 4 power. Finally you have to get this thing. The thing is the power of the source. Power of the source will be equal to the power received by the R1, power received by the R2, power received by the R3, power received by the R4. Understand? That means this is the source. This will supply the power to 4 ohms resistor, 2 ohms resistors, 2 ohms resistors, 4 ohm resistors. So this power will be each and this will observe the power, this will observe the power, this observe the, this is observe the power. That's why I write these equations. If you find out the each and every power, then your currents will, your answer will be correct. If it is not satisfied, this is not correct. Understand? He can ask the, in any circuit or any network, he will ask the find out the current or voltage or power. Then you have to follow the principle. This is the one method. This method is loop analysis. This method is loop analysis. So this is the this is the BW subject. In this BW subject, you have to maintain the nodes, the separate nodes. By that separate nodes, you have to write each and everything which is taught by me, which is taught by your sir. Then it is very easy. Just listen here and note each and every point of the class. Then you will understand each and everything. Okay. This is about the mesh analysis or loop analysis. Right. Hello students. This is the second method, nodal analysis. So already we discussed about how to solve a circuit by using the mesh analysis. Now the nodal analysis. So already regarding the nodal analysis, we already discussed theory regarding about the nodal analysis, right? So in this nodal analysis, I take in same question because the comparison is very easy, right? The same question. In this, the given circuit, first you find out how many nodes are available. How many nodes are available. So better to write the circuit, better to write again, redraw the circuit. We will make some modifications. A 4 ohms resistor and here the 2 ohms resistor. We have the 2 ohms resistor. Again we have the 4 ohms resistor. 2 ohms resistor. The supply is 10 volts source. First you have to look at how many nodes are available. First you look at how many number of nodes is available. Here look at here how many nodes? Only one node. This is not a node, this is not a node. The same current is flowing. Number of nodes is 1. So automatically we have one nodal equation. We will get the one nodal equation. So in order to write the one nodal equations, first we have one node. Assume that at one node we have V voltage is there. First assumption, V voltage is there. Assume node voltage V. And second assumption, assume all currents are leaving from node. These are the assumptions only. All currents are leaving from node. So I am assuming that we have from the node we have this is a one branch, this is a one branch, this is the one branch. So I assume that we have three currents are there. One is this I1 current is leaving from the node, this is the I2 current is leaving from the node, and this is the I3 current is leaving from the node. This is the assumption only. So all currents means we have three currents, just I1 and I2 and I3. I1, I2 and I3. Now you have to write the nodal equation. Nodal equation, now you have to write the nodal equation. How we can write the nodal equation? By applying KCL. Simply by applying KCL at node. KCL at node. By applying KCL at node. You better to take the third point, no problem. So what is KCL? At a node, all the currents are leaving is equal to all the currents are entering at a node. But here we are assumed that all currents are leaving only. So simply, so I1 plus I2 plus I3 is 0, because we are assuming all the currents are leaving, all are leaving. No current is entering into the node. That's why I1 plus I2 plus I3 is 0. Now we will write I1 value and I2 value and I3 value. Now you have to write the I1 value. Now this is a very important thing. Actually the current I1 is nothing but it is flowing from V to 10 volt source. It is V to 10 volt source. In order to flowing the current from one point to another point, it must have the voltage difference. Voltage difference, and the voltage difference by resistance is nothing but current. Simply you can write the current value is like this. Current is simply voltage by resistance. Voltage by resistance. For example, we have two voltages V1 and V2 by resistance. Now we will write the current value is like this. Now we will write the current value is like this. That is current is nothing but voltage drop by resistance. Voltage drop means the voltage between 2 points and the resistance between the 2 points. That's why we can write V1 minus V2 by R. If the current is flowing in this way, down way, if the current is flowing in up way, then V2 minus V1 by R. So by using that we will write the each and every equation. From that I1, so here current is flowing from this voltage to this source. So that's why I can write I1 values like this. The I1 value is voltage drop. This is the voltage V and this is the voltage drop 10 volts by the resistor. Resistor is 4 ohms. Don't confuse here, right? Don't confuse here. This is about the I1. This is about the I1. And every circuit have some ground. Ground is nothing but it is operated at 0 volts. Every circuit have ground is operated at 0 volts simply. So for that I2 is same voltage difference between 2 points and by the resistor. So here the voltage is V, current is flowing to 0 volts. So 0 by the resistor in between 2 points, resistor is 2. Resistor is 2. This is about I2. This is about the I2, right? Next, what about I3? I3 current is flowing in this way and it entering at 0 only. So I3 is, I can write like this. The voltage is V and it is flowing to 0 volts by the resistor. Resistor is 2 plus 4 ohms. This is the 2 plus 4 ohms. Value is 0. This is the 0. Understand? This is the very, very important thing. If you understand this, concept, nodal concept, you will do each and every problem very simple. In the problem he is given very bigger network, but by applying the nodal is very, very simple. If you compare with the KCL and KVL, if you compare with the nodal analysis and mesh analysis, nodal analysis is easy, but you assumptions and writing the current equations is the important here. Right, look at here. Again I1, this is the I1 is flowing. Voltage difference between 2 points and resistor, look at here. It has a V volts, it has 10 volts by 4. This is the equation. For the I2 current look at here. I2 current V here, 0 here. V minus 0 by resistor. Why here? By Ohm's law, I equal V by R. Next, in between V and here I3 current is flowing in this way. So V minus 0 by 2 plus 4, because both are in series connection. Both are in series connection. Now you write here, simplify here, V minus 10 by 4 plus V by 2 plus V by 6. V by 6. Next, you have to solve the above equation. In order to solve the above equation, just find out the LCM. For this 4, 2, 6, LCM is 2 times, 2 1 time, 2 3 times. So now LCM is 2 into 4, 4 into 3. LCM is 12. So LCM is 12. So this is the LCM, and 3 into V minus 10 here plus 6 into V here plus 2 into V here equal to 0. Because 4 in 12, 3 times cancel. 12 is there, 6 times cancel. 6 is there, 2 times cancel. Now if you simplify this, 12 becomes 0 and this is the 3v minus 30 plus 6v plus 2v equal to 0. The equation, so solving, if you solve this, you will get 3v plus 6v plus 9v. This is the 11v and this is the 30 equal to 0. Then the v value is 30 by 11. If you solve this, you will get 2.72 volts. 2.72 volts. Understand? Now you will find out the each and everything, and you have to compare this. What is I1 value? Simply, what is I1 value? I1 value is 2.72 minus 10 by 4. If you solve this, you will get the I1 value is simply 1.82 minus 1.82. This is the I1 value. What about I2 value? I2 value is V minus 0 by 2. V minus 0 by 2 means V means 2.72 by 2. 2.72 by 2. You will get 1.36. And what about I3 value? I3 value is 2.72 by 6. 2.72 by 6, you will get 0.45. 0.45. From that, you can simply find out, look at here, this is I2, current across. If you compare both the equations, you will get, but here small thing is there, but actually the source current is, what about source current? Generally, the current is from source flowing from this point to this point, but we are assuming this point to this point. That's why we will get minus here. That's why we will get minus here. So now the source current is opposite of I1. So source current you will get minus I1. Minus I1 means minus of 1 point minus 1.82. You will get 1.82 amperes. Understand? 1.82 amperes. Same thing. So if you compare with the KCL, you will get same thing. There ISC is nothing but I1 1.82. I2 is 1.36. I2 is 1.36. This is the I3 is 0.45. So if you compare the KCL and KVL, you will get the same currents. Now you can find out each and every current. Look at this ISC is, then ISC, this value you will get, this value you will get, this value you will get. Right? Whenever, look at here again, this is the lower voltage value, this is the higher voltage value. Lower voltage minus higher voltage, you will get minus here. So for the circuit, generally source will supply the power. But in the nodal analysis, in order to become easy, we are assuming this way. That's why we will get minus here. Understand? So if you compare the KCL values and KVL values, you will get the same value. Look at here. So this is the nodal analysis. Nodal analysis. These are the steps. The first step, how many nodes are available. Second step, so from the node, all the currents are leaving. That's why I am taking I1, I2, I3. Next step, apply the KCL at node for these currents. So by writing the current equations, very important. In order to write a current equation, voltage by resistance. But in order to write the voltage between 2 points. The voltage resistor is this, but voltage at one side we have V, another side 10, V minus 10. Here, in order to write the 2 ohms resistor, one side V, another side is 0. That's why V minus 0. Next, for 2 plus 4 both are 6. So V minus 0 by 6. So by solving this, we will directly get the voltage value. From that voltage value, we can find out each and every current. Each and every current. Now we can find out each and every current of the element. Each and every current of the element. Understand? So generally at nodal analysis, if you observe here, what is this meaning means, I will explain here what is the meaning means. So V 2.72 means, here just take it, this voltage value. For example, this voltage value, assume that this is the V1 value, and this is the V2 value, and this is the V3 value. All are same. All are same. That means this drop of the branch and this drop of the branch and this drop of the branch is same. The branch is same. That's why V value 2.72. Look at here, 2.72. This value 2.72, this value 2.72, this value 2.72. You got some doubt here. Voltage source is there. How it is 2.72? Here with voltage source we have a resistor is there. This is the positive and this is the negative. This is the positive and this is the negative. That's why you will get there. So at every parallel branch the voltages will be same. Every series branch the currents will be same. Look at here. This is the one parallel branch, this is the another parallel branch, and this is the another parallel branch. That's why the each and every parallel branch the voltage will be same, but current is different. Current is different. So that's why here V is nothing but V1 is nothing but V2 is nothing but V3. This is the parallel branch. This is the parallel branch. Understand? This is about nodal analysis. And in the before classes, we will discuss some more problems. Then the nodal analysis is very easy. Nodal analysis is very easy. But this is the basic thing. This is the basic thing. This is about nodal analysis. Okay.